Hello students, now we will observe some observations on FA. Some important points on FA that we need to observe here. Look all of you, point wise we will observe. The first point I want to trying to say, like the empty string epsilon. You know, right? Empty string. Epsilon is not empty string. Empty string epsilon is accepted by FA if and only if initial state equal to final state. This is very important point you understand. So I'm repeating the statement. The empty string epsilon is accepted by FA if and only if initial state equal to final state. Then we can say that is accepted, because simply Q0 is initial state, right? Q0 is initial state. So if I make it this is a final state, that you understand this will accept epsilon. Epsilon is empty string, nothing, just nothing. It is not any string or any symbol. This emptiness, empty also will accept. So when it is going to be accepted, when initial state becomes final state, that you would understand. Second point I on all of you. FA without final state accept the empty language, right? FA without final state accept empty language for phi. Phi is empty language only. We will understand how the FA will accept the empty language here. If you see the example for this here, suppose Q0 is there. Q0 on A comma B, it is repeating for this only. This will accept empty language. How? See, if you take string W equal to AB, whether W equal to AB is process or not, yes, it will process. See, Q0 on A, Q0 on B, Q0 only. See, so we are reaching to where? We are reaching to where? Q0 on. Q0 is a non-final state, correct or not? The string is rejected or not? Whatever the strings if you give for this, it is rejecting. Rejecting nothing but nothing will accept. Nothing will accept nothing but what? It will accept what? Empty language. That you would understand. W equal to whatever string you give for this FA. It won't accept. It won't accept nothing. There is no final state here. So it won't accept this string nothing but what is accepting? Emptiness. Empty only will accept. When I say empty language, even epsilon also not accepted. You must understand. When I say it is just accepting empty language, nothing but you understand L equal to empty, not empty set here. Even this does not containing what? Epsilon. I think this note point I given in previous session also. Emptiness nothing but empty language containing no epsilon, that you understand. So this write on the point all of you. And third observation, third point you write, FA in which all the acceptance or unreachable accept the empty language. Means suppose FA in which all accepting states, suppose accepting states are unreachable. If you have an unreachable state, definitely that is also going to be accept what? Empty language only. We will understand it is also accept what? Empty language. I'm telling. Suppose first one under which, suppose Q0 on A comma B, it is repeating self loop, assume that, and another state is there, Q1 is a final state, is also repeating A comma B. This is FA, one FA. This will accept empty language. See, in this FA, finite state is there, so final state is there, but final state is not reachable to what? Initial state. Final state is not reachable to initial state. That is nothing but whatever string you given to this FA, that will be at Q0 only. Q0 always reject. When for each and every string it is rejected, that is nothing but it is what? Accepting what? Empty language only. I am repeating the statement. FA in which all the acceptance are unreachable and acceptance states are unreachable, then that accept what? Empty language only. Second example if I give, so Q0 on A comma B, Q0 on A comma B, let me take B. So Q1 is the final state and on A it is self loop is there. This also will accept what? Empty language only. See, so Q0, so Q1 is a final state is not reached to Q0. See, direction is different. So Q0 to Q1 to Q0 is there, but we don't have a transition from Q0 to Q1, correct or not? We have a one, like 1 to Q0. So it is coming on B, but is not going to Q1. That is nothing but each and every input string if you give, that will be repeated Q0 state only. That is always rejecting nothing but it is accepting empty language. Under 3, third note I given, under which third case I am giving. So like I am giving different example, different cases where it is accepting empty language only. Third one, if you see, all of you, like Q0 Q0 on A comma B. So transition A Q1, final state is repeating B. This also same, accept empty language only, yes or no? This is accepting what? Empty language only, yes or no? So similarly, fourth one, if you see under this only, suppose Q0 A comma B, A comma B Q0 only on B Q1. Q1 is a final state, is repeating A. Then another state is there here, Q2 also final state, on A is coming, for this it is reaching B, repeating B. So simply Q0 is initial state, Q0 on A comma B Q0, and Q1 on A Q1 on B Q0, Q2 on A Q0, Q2 on B Q2 only. So these two final states are the which are unreachable to initial state. Definitely this also accepting what? Empty language. So third point clear, all of you? What I'm trying to say, third point, FA in which all the acceptance are unreachable, definitely that is going to accept empty language. Yes, these are the four examples enough to understand this is accepting empty language. Now fourth observation, all of you note down fourth point. So these are going to be help us a lot for solving questions. That is the reason I mentioned the topic name is observations on FA. FA in which all the states with the final state accept universal language. FA in which all the states with the final state, accept universal language sigma star. So we will understand the example only. Suppose Q0, this is initial and final state, and A comma B is there. Now it will accept or not? What it will accept? So sigma star it will accept. Please do understand. W equal to epsilon will accept, yes. W equal to A if you accept, yes. B will accept, AB will accept, BA will accept. That's simply sigma star epsilon A comma B comma AA BB, like any number of string will accept or not? Yes. This is going to be accept universal language, that is sigma star. Whatever string you give, that will accept, means that is nothing but in FA in which all the states are final. So FA in which all the states with the final state, all the state with the final state, nothing but all states are final states only. Suppose second example if I take, Q0 on A Q0, so Q0 on B Q1, Q1 on B Q1 only, then Q1 on A Q0 is there. So this will also accept what? Sigma star or not? Universal language only. Epsilon will accept, A will accept, AB will accept, AB will accept, all things are will accepted or not? Yes, this way you understand. So FA in which all the states are final state, definitely that is going to be accept all strings of sigma star or not? What is sigma? A comma B alphabet if you take, sigma star nothing but what? What is sigma star is containing? I have told all of you, sigma star is containing sigma power of 0 union, sigma power of 1 union, sigma power of 2 union, sigma power of 3 union, like this. 0 length, 1 length, 2 length, all length of the string is available. So definitely that is nothing but universal language will accept. This is a fourth point which is important for us now. Please note down. Next, fifth point. Right now. FA in which initial state is final state and all the non-final states are unreachable. Then accept what? Again, accept universal language only. So what I am trying to say, FA in which initial state is a final state and all the non-final states are unreachable, then also it will accept universal language sigma star. Check it with example. Example 1 I will take. Suppose Q naught is the initial state. I will make a final state. Suppose A comma B is there, and non-final state is there in which Q1 on A comma B is there. So this is accepting L equal to sigma star only. How? See, Q naught is the initial and final, and repeating for A comma B only. So Q1 also repeating for A comma B, but is not reachable to Q naught. So this will accept universal language. See, epsilon will accept 1A, 2A, n number of A's, B's, AB, BA. All combination will reach to final only, correct or not? Initial and final, it will accept universal language. Suppose second example. Q naught is initial and final. Yes or no? Initial and final. A comma B is there on Q1. Q1 on A, Q1 on Q naught is there. Q naught on B, Q1 on B, Q naught. Q1 on B, Q naught is there. So now see, this is also will accept what? Language sigma star. It will also accept sigma star only. How? See, Q1 is a non-final which is not reachable to initial state, because initial state itself final only. Definitely will accept what? Again, if we have a given transition for A comma B here, definitely will accept universal language. Are you getting all of you? Yes. Next is sixth point. We must note down sixth point. Sixth point, I don't know. Every FA accept only one language. Only one language. This is very important point. Whatever FA you draw, only one language will accept. Comma, a language is accepted by, write down, a language accepted by a language accepted by more than one FA. A language can be accepted by, can be, write down, language can be accepted by more than one FA. More than one FA. Then we can say that is FA is not, that is FA is not unique. That is very important. The FA is not unique. Means what I'm trying to say, suppose whatever FA you draw, suppose some FA is there, definitely will generate only one language. Accept only one language. Whatever language you given, only one language will accept. Are you getting my point? But any language you take, for this many FA we can construct, like this FA1, FA2, FA3. Like with the different state you can understand, different nature I can construct. Are you getting my point? For given a language, we can construct different FAs. One FA, one language will generate. Are you getting? One FA will accept only one language, but language accepted by more than one FA. So definitely this FA is not unique. I may not have a unique FA for language. Can get? That's a point you can understand. So FA is not unique. That is the reason we are going to minimal FA, you can say. Next, seventh point. Seventh point, write down all of you. FA which is free from unreachable and equal state is called minimal FA. Right now, FA is free from unreachable and equal states. Equal state is called unreachable, equals is called minimal FA. Is called minimal FA. This is very important point now. See, in FA, unreachable states and equal states, if unreachable and equal state, if you remove whatever resultant FA you will get, that is nothing but minimal FA. This is further cannot be reducible. FA can be reducible, minimal FA cannot be reducible. That is nothing, understand. This only minimal means it is containing minimal number of state which is going to be accept the given language. So next point right now, eighth one right now. Every language is accepted by only one minimal FA. That is minimal FA is unique, right now. Every language is accepted by only one minimal FA. So then therefore minimal FA is unique. Are you getting? Minimal FA is unique means, so for given language I don't have a more than one minimal FA. For any given language we don't have a more than one minimal FA, but definitely we can have a more than one FAs can be have, but minimal FA cannot be have. So you can ask the question, what is the difference between FA and minimal FA? Nothing. FA we consider for language, right? Finite automata. In this finite automata, sometime what happens, some state will be there which are unreachable state, unnecessary it is containing. Unreachable state, unnecessary containing. I will give example. And some state may be equal. So two or more state may have same nature. Such cases, if you remove the states, if you remove unreachable and equal state, then definitely we'll get minimum number of states only, right? Whatever the minimum number of state we'll get for that FA, that is nothing but minimal FA. So minimal FA definitely unique. So for one language, only one minimal FA will be there. But for FA, we can have more than one. Per language, we can have more than one FAs. FA accept, right? One note point. FA accept what? Language. Correct or not? FA accept language. This L, for this L, I can have a FA1, same thing I told you, FA2 and FA3. But FA accept the language. This language is accepted by minimal FA is definitely unique. Minimal FA definitely unique. FA cannot be unique as I mentioned. Are you getting? So these are the major important observations we made, like understanding empty language, how FA will accept empty language, how FA will accept universal language, and what is the minimal FA that we observed. Again repeating for minimal FA, many times I am going to observe minimal FA. Minimal FA nothing but you understand that FA you cannot further divide, further reduce, further reducible, meaning you understand you cannot reduce the number of state further. That is the minimal. That is only minimum number of state definitely required to construct a language. So initially you can consider the FA in which you remove it, then that becomes the minimal FA only. Okay, fine. Thank you so much.